So let's continue on now and look at section 2, or questions 2 and 3 from midterm exam number 2. As we do this, we see that this is going to become a present value equation, where we're looking at a human capital investment, so that we're going to use the form of an equation of present value being equal to the sum of beta t, and beta t is just a series of cash flows at time t, where there's multiple time periods, divided by 1 plus the rate to the t. It's hard to see that that's a plus, but it is. So 1 plus the rate to the power of t. So let's look at the relevant material here. In this story, we're told that John is considering taking a year off from school, or rather taking a year off from his job that currently pays him $45,000 to go to a technical school. It'll cost him $20,000 up front, during which time he'll only earn half of his income. At the end of his training, his employer will pay $10,000 to relocate him to a new city. So that's a bonus. He's going to pay him that, even though the expected cost of the move is only $5,000. It's important to remember that John's only going to experience that cost and have that bonus as a function of him participating in this investment and then relocating. He's then going to receive a 5-year contract at $70,000 a year, so this is a certain item, and after which time he expects to retire. So we have a limited time frame to account for here. 1 year of the technical school and 5 years of his employment contract. He has a personal discount rate of 3%, which, by the way, is a very low personal discount rate, and it would be reflective of the fact that John's doing all this within the framework of the existing employer, and he's doing it under a contract, and he's getting some pretty meaningful benefit for doing this. This is kind of a sure thing for John, but still he's wanting to analyze this, or wanting us to analyze it for him perhaps, to decide whether it really is what he thinks it is. And so you're finally told that assume incomes and expenses are accounted for at the end of each period unless it's otherwise specified, and it's not. So what have we put together here? Well, first I'm looking at this tuition of $20,000. It's a negative to John because it's money he's spending, and it's at time 0. Well, at time 0, we're going to use the exponent 0 to indicate that there's 0 time between right now and the upfront expenditure, which happens right now. So we then are going to look here and we see, well, there's a $10,000 bonus he receives at time 1. So this is the end of time period 1, at the end of his schooling, when he's now moving to the new job in the new city. His current income is $45,000. His income while in school is half of that, so $22,500. His future income is expected at $70,000. The total time that we're going to account for here is 1 plus 5, so 6. And we have a rate equaling 3%. And then there's this expense for the relocation of $5,000 at time T1. So let's put this together. So our first term is going to consider the immediate expenses or cash flows at time 0, which is now, and the only one we have is this payment of a $20,000 expense. So we have a negative $20,000 here at 1.03 to the power of 0. It's important to understand that any value to the power of 0 becomes 1, which essentially means that this $20,000 is really $20,000. It's not time discounted at all, so this net present value is $20,000. In the next term, which is going to be at time 1, so it's divided by 1 plus r to the power of 1, or 1.003 to the first power, we're going to have to think about what expenses and benefits come about in this period. Well, he's going to give up half of his income. So he gives up $22,500 in income. That's an opportunity cost, but it's a real cost in this case that he's giving up because he's participating in this education experience. At the end of this period, he's going to get a $10,000 bonus. So that's a positive. And then at the end of the period, he's also going to spend $5,000 in a moving expense. So he's going to have a negative 22.5, a positive 10, and a negative 5, which I believe is going to give us overall a negative 17,500. That's what that equates to. And this is divided by 1.03 to the first, which happens to work out to be negative $16,990.30. We then see that for each year, starting at time 2 through time 6, so 5 years, starting at time 2 through time 6, then we simply have a positive value. And in this case, it's $25,000 each year, which happens to be the difference between the $70,000 future income based on his contract, and his $45,000 current income. Here we are, his $45,000 current income. The difference between those, or the income change, cash flow change, he'll experience as a function of participating in this investment is $25,000, and it's a positive. Well, if we look at those values, they equate to $23,564.90 for period 2, $22,878.54 for period 3, $22,212 or $22,212.18 for period 4, $21,565.22 for period 5, and $20,937.11 for period 6. Note that the same $25,000 that's used as our cash flow is resulting in a lower and lower and lower net present value as we are adjusting it for time, which makes sense. A $25,000 today is $25,000. Tomorrow it's a little bit less. 5 years from now, it's yet less still. 10 years from now, it's yet less still, because time discounts it for this discount rate, which you might think of as kind of an inflation issue, perhaps. Well, the sum of this, then, is $74,167.65. This is our present value. This tells us the value that John is going to receive over and above that which he requires based upon his discount rate. When we compare this to 0, which if it was 0, it would be telling us he'd be receiving exactly the value he expects given his discount rate. But given that it's so much greater than 0, this is even better, and so John is going to choose to make that investment. So the second part of this is item B, and so I'm saying suppose John enjoys a utility function such that his utility is equal to a function of wage, family, and recreation. So W, F, and R. So this is his utility function. So if this is the case, if John takes the job, as we've just suggested he probably will, then explain what this decision might suggest about the relative weights in his utility function of W, F, and R. This might be a little bit ethereal for you. You had to be paying some pretty good attention to some of the video modules on in this section of the course to get this inference. But what it suggests, if he's going to make that move, that he values wage greater than he values family and recreation in this utility function. Doesn't mean that he doesn't value family or that he doesn't value recreation. It means that he values wages more. So that's all that it means. So as we look at C, I ask how might we envision John's utility function of his income and the goods he might be able to consume. We're looking at only 2 goods available in this very simplistic, and we went through 2 or 3 different examples of this very type of model within the this utility and human capital investment section, such that we can create what's essentially a consumer optimization. Where we have a budget for the consumer, which in this case, John's budget is going to be $70,000. That's his new income. And we know that he can buy 2 different goods. In this case, we're saying goods X1 or X2. And we know from some of the material we looked at that we can identify the number of units that we would be at here on this X2 axis, or this Y-axis, X2 axis, as being X2. The number of goods divided by some price. And that's going to tell us how many he's going to, that's going to be budget divided by some price. It's budget divided by the price of X2. And we're going to see the budget divided by the price of X1 on this axis. And that's going to tell us how many units of X2 John could be purchasing with his budget. And this will tell us how many units of X1 John could purchase with his budget. And we know that at the point at which the indifference curve, the utility curve, is tangent to the budget curve, tells us how many John has decided to buy, and this is all based upon his tastes and preferences, expending as a constraint his budget. So X2 star and X1 star. Okay, so that was number 2. Number 3 is another Roadhouse ribs equation. And in this case, we've said that Roadhouse ribs is chosen to pay workers less than marginal revenue product of labor so the firm can earn a profit. Okay, not uncommon perhaps. The longer someone works at Roadhouse, the more they get paid. Also, not uncommon. And at some point, the firm might start paying a worker more than they produce. So we're thinking about a point in the future here where we might have wages that are greater than marginal revenue product of labor. We have a typical worker that's got a marginal revenue product of labor curve of 10 plus 0.2t. So marginal revenue product of labor equals 10 plus 0.2t. Separately, we have a wage equation that is wage is equal to 8 plus 0.3t. So W is equal to 8 plus 0.3t. Those are the two equations that we've got. And we're looking at this saying that T equals the number of years the worker has been at Roadhouse. And MRPL, or marginal revenue product of labor, is measured in dollars, as is wage, of course. And so I begin by asking you, what's the number of years it takes one of these workers to earn more than their marginal revenue product of labor? So try to envision this, if you will. Let's envision it in a graph. And you've seen this graph. You did a problem on it, one of the review problems. You saw it in a video module where we have some upward sloping curve, as noted by the positive sign in front of the scalar. And we have actually two graphs, or two curves that are going to be upward sloping. But we'll think about this first one, and we're going to be looking at this in time and MRPL, marginal revenue product of labor, and wage space. Marginal revenue product of labor and wage are also always currency denominated. Time is always unit denominated. So they occupy the Y and X axes respectively. So let's see. This first curve, this marginal revenue product of labor curve, is at 10 plus 0.2t. All right, well, if t equals 0, which it does right here, if t equals 0, then this equals 10, and this is the MRP of L curve. Now let's think about the wage curve. Well, when time is 0, then wage is equal to 8. We're still on this currency denominated axis, so we're here. We're here on the curve at 8, and we know that it's got a slightly steeper slope, 0.3t instead of 0.2, which tells us that we're going to be more steeply upward sloped, which we also learned in our description, indicating that we are starting with a wage that's less than our revenue productivity, and at some point we get to a wage that's greater than our revenue productivity. And we're trying to identify when that is. Well, as it turns out, it's right here at T star, and at T star we have some W star. Well, in order to do this, we have to then find a way to identify this particular point. I'm not asking you to draw the graphic. Some of you indicated after taking this exam that you wished I had, and my response was, well, you are welcome to do so, I just didn't require it. And a few of you actually did, of course. Being able to visualize these, as I gave you the visualizations in the videos and the review problems and such, even in one of the supplemental problems that I sent to you via email, may have been helpful for some of you. Well, in order to find this point, we have to make an assumption. And that assumption is that the marginal revenue product of labor is equal to the wage. Now, we know that time is equal to time. That's easy. But if we know the marginal revenue product of labor is equal to the wage, which it is in a competitive labor market, so we have some precedence for this, now we can just consider that these two equations can be set equal to each other. We can substitute W for MRP of L. W equals W, so we can say that 10 plus 0.2t is equal to 8 plus 0.3t, or we can then go ahead and look at this and say that 0.1t is equal to 2, or t is equal to 20. So T star is equal to 20. All right. Well, if t star is equal to 20, then, using some of the same algebra we've used so many times in this course, we can take this value of 20, plug it back into either of these equations, and we can then find the value of W or W star. So let's put it into this marginal revenue product of labor equation of 10 plus 0.2 times 20, and that's going to equal our wage, in this case, which is going to equal 14. Here's our wage star. We could have put this into the wage equation. I used the marginal revenue product of labor equation just because mathematically it's slightly simpler for me. But if we had used the wage equation, we would have gotten to the exact same 14. So 14 is W star, which simply tells us that from time 0 to time 20, this worker will be paid less than they're actually earning for the firm, during which period, of course, the firm is accumulating some surplus. We'll just kind of fill this in. The firm's accumulating some surplus on top of that worker. Well, the next question is, how many years will it take before Roadhouse starts losing money in the aggregate? So as the sum of the entire experience on this worker. Well, let's look at this. Since these are straight lines, and they're hardly straight with my drawing, but you can tell that they are straight lines given our equations here. Since those are straight lines, then we know some things about them. We know that the angle, let me kind of get rid of some of this. Oh, excuse me, I don't want to do all that, but I'll put this back in now. We know that some of these angles are the same. I know that this angle right here is the same as some angle that I might have out here if I'm looking for another point in time. This angle here is the same as this angle here. This angle here is the same as this angle here. So when you have something where you can say that, now we know that the buildup of this accumulated surplus that we're looking at will be exhausted in exactly 20 additional years, which will give us a triangle virtually identical on the right side of 20 as we have on the left side of 20, such that we have some t prime equaling 40, because it's going to be the exact same number of years. And most of you pegged that, of course. So in Part B, I'm asking you to tell me at what point they start losing money in the aggregate. So at what point have they completely depleted all of this built-up surplus that they got while the employee was paid less than they actually produced? How long does it take them to exhaust that when the employee is being paid more than they produce? Well, if it took 20 years to get it and these lines are straight, it takes 20 years to exhaust it in this case. And so I was looking for a value of t greater than 20. Or even if you had said that t equal 20, I would have been fine with that. The problem I saw many students having on this, if you understood the question at all, was instead of looking at this in the aggregate and realizing that we were building up a surplus, and then how long would it take before we lose money in the aggregate, so the net of the experience, too many students just said time 20, anything beyond time 20, which the firm hasn't lost money there. They are actually reducing that which they gained. They've yet to lose. So I then asked the question in Part C, why might Roadhouse choose to keep a worker and its employee for more than 30 years? Well, at time is equal 30, then the firm is paying the worker more than the express productivity provided, so there might be some risk there. This might be something we have to think about. But there might be some benefits that this worker brings to the table that aren't easily measurable through marginal productivity or marginal revenue productivity, such as loyalty to the firm. And some of the benefits that we gain in a work environment where one or more of our employees are very loyal. It helps other employees be loyal, which means we have less turnover. Maybe we're using this person as an example or a role model or a trainer. Maybe we're using this person for other social and or political activities within the firm that their length of term, their institutional memory provides us. So any discussion that you might have offered me that included those kinds of values received the necessary points on this. Many of you simply offered a discussion of marginal productivity of labor and wage and really missed the point as to why the firm might choose to keep them. You may have given me facts, you may have given me good information, but really didn't address in too many cases why the firm would make this choice. The firm would be making the choice if there were some benefit that the worker brings to the table that aren't easily measured in marginal revenue productivity. And then finally, I say, given the initial relationship, and remember the initial relationship is where the wage is less than the productivity. Given the initial relationship between wage and marginal revenue product of labor at Roadhouse, what does this suggest to us in respect to the relative power relationship between workers and producers in this market? This part of this question comes directly from one of the review problems and supplemental problems I gave you. And so if we've got a scenario in which this firm is being able to attract workers at a value less than they actually are going to produce for the firm, then there must be some power that the firm has over workers. Maybe it's a tight labor market, maybe it's a very loose labor market where there's a lot of unemployment, and maybe if I'm unemployed, I'm willing to go to work for a wage that's less than I know I'm going to produce, but is a lot more than the zero I'm getting paid now. Or maybe it is a job that the producer has some power over me in the early stages because I know that if I'm there for a long time, then I'm going to earn a lot more, or I'm going to be paid a lot more than I earn. I want that. That's very attractive to me, so I might let the firm exploit me a little bit in the early phases. There are a number of different reasons that this might be the case. Perhaps training. Maybe the firm is going to give me some training at their own expense, and so I'm willing to take that training plus my wage as my total compensation package, and I've justified it with my productivity. Or maybe there's a union contract of some kind that kind of sets all of this out. I don't have to worry about being fired in this period after I've gotten past this break-even point here, if you will. I don't have to worry about being terminated in the future because of this union contract. Something like that is going to have to be inherent in this power relationship.